All right. So today we're going to continue going through the history of astronomy, focusing mainly on the ideas people had, not necessarily every historical event that happened in people's lives. So when we left off, we had already talked about how ancient people used astronomy, mainly for navigation and telling the seasons to help them live more stable lives. But again, we said that you don't necessarily need to know why the stars move the way they do in order to be able to do those things. And so it took a long time for people to start actually trying to apply a scientific method to figuring out why the stars do what they do. And it was about 2,000 years ago, a little over 2,000 years ago, that the ancient Greeks started really looking into this question. And they started trying to figure out, okay, if this is what we see, what is the universe actually like? What's it shaped like? Where is everything? Where are we? Where are the stars? Where's all this stuff? Okay? And so what we're going to do is we're going to start just building up. Let's just start drawing a diagram of how they thought how they thought the whole universe worked. And we'll start with what they thought was in the center. Okay? So the ancient Greeks were trying to figure out what was in the center of everything. And they actually came up with two ideas. They came up with two major ideas for what was in the center of the entire universe. And does anybody know what those two ideas are? What were the two possible things the ancient Greeks thought might be at the center of everything? Give me some guesses on that. What's at the center of the universe according to the ancient Greeks? Or what were their two major ideas? Yep, one was the Earth, and one was the Sun. Okay, so they actually, a lot of people know that the ancient Greeks thought that the Earth was in the center of the solar system. But they actually did come up with the idea that the sun was in the center as well. So those two ideas are called a geocentric system and a heliocentric system. There we go. So geocentric and heliocentric. And which one of these is for having the Earth in the center of everything? Which one of these is Earth-centered? Geocentric or heliocentric? Yeah, geocentric means Earth in the center, because geo right here, that means Earth, so Earth center. And helio actually means sun. So anytime you see helio, and we're talking about the sun. So heliocentric means sun in the center, okay? They had both of these ideas. Does anybody know which one they decided to go with ultimately? When they tried to apply the scientific method to this, when they tried to put up tests, which one did they... Yes, they went with geocentric, okay? So even though they had both of these ideas, they decided to go for geocentric instead of heliocentric. And there's two main reasons for that. Why did they pick that one? Two main reasons. One of them is a good science reason, and the other one is a bad science reason, okay? In fact, one of them is a scientific reason, and one of them is not a scientific reason. So let me explain the bad reason that they went for geocentric first. Heliocentric idea. Who came up with it? The heliocentric idea was mainly thought up by a guy named Aristarchus. So, yes or no, real quick. Aristarchus. Give me a yes or no. Have you heard of this guy before? How many of you have heard of Aristarchus? Yes if you've heard of him, no if you haven't. No. Exactly. Probably you don't... You probably have never heard of this guy because they didn't ultimately go with his ideas. But the main person who was pushing the geocentric idea was a guy named Aristotle. So Show of yes or no, who here has heard of Aristotle? Exactly. And if you had asked random ancient Greek people on the street, they would have also known who Aristotle was. They would not necessarily have known, just random people wouldn't have known Aristarchus. Aristotle was a very famous scientist back then. He was famous for a lot of things, but one of the things he was famous for was science. And he actually had done a lot of really good science. He had come up with a lot of good, well-supported ideas. But that made him more popular. And so basically a lot of people decided that he must be right because he was a famous, smart guy, right? It's kind of like he was sort of like the Einstein of his day. Like if you heard Einstein figured this thing out, you're kind of likely to think he was right. But even Einstein wasn't right all the time, right? So one reason people went with the geocentric model is that it had good, popular people setting it up. That's not scientific at all. You can't just trust a scientist. You gotta look at the work, right? So what's the better reason they went with geocentric? Well, again, they applied the scientific method. They used observations and tried to figure out which one of these made more sense, okay? And here's the thing. The ancient Greeks knew that the sun was really, really, really far away. Because even if you went to the top of a mountain, the sun didn't look any closer. So that tells us it must have been really far away, right? And they also knew that the patterns the stars made in the sky took 1 year to come back to the same spot. That's what we were talking about a couple of classes ago. So they knew how long it would take either the sun to go around us, it would be 1 year, or for us to go around the sun, that would be 1 year. And if the sun is really far away, let's assume that the sun is in the center of the solar system. Let's assume the sun's in the center. If the sun is in the center, and we're really far away from it, and we have to go all the way around it in 1 year, what does that tell us about the speed of the Earth? Is the Earth going to have to be fast or slow to get around the sun in 1 year if it's really far away from the sun? Fast or slow? Fast. Yes. It would have to be fast, right? And that means that if the Earth is moving fast, we must have some kind of evidence that the Earth is moving really, really fast. So we're standing on a thing that's moving really, really fast. And remember, right now, I'm talking through the ancient Greeks' line of logic, okay? Which we'll see is a little bit flawed in a second. So check this out. Did ancient Greek people go really, really fast? Not really. They didn't go really fast. What's the fastest thing an ancient Greek has probably ever done? It's probably riding something, right? What were they probably riding to make them go fast? Yeah, probably a chariot, maybe a horse, right? A horse or a chariot, one of those things. Something that was horse-powered, right? And so let's imagine that you're riding a horse or a chariot and you're going really, really, really fast, like 100 miles an hour or something. Which I don't think horses can do. That would probably kill that horse, but let's just assume you're going like maximum horse speed, okay? So you're going real fast. Even if you close your eyes, you'd be able to tell you were going fast, right? You'd be able to tell that you were going really fast on a horse or a chariot. Even if it was on really smooth ride. Like, what's going to happen to your hair? If you're going maximum horse speed, what's going to happen to your hair? What'll happen? Pretty simple things. Yeah, I'll just go ahead and say it. We all kind of know what's going to happen here. It's going to be blown back. Oh yeah, there you go. It's going to be blown back. You might feel it on your face. You're going to feel wind going past. So here's the main question. Do any of us right now feel wind going past us. Do we feel wind going past right now? No, we don't, okay? We don't feel wind going past. But going really fast makes it so you should feel wind going past. So based on that line of logic, what does that mean? According to the ancient Greeks, if the earth was moving really fast, we should feel wind. But we don't feel wind. So what did the ancient Greeks conclude? What conclusion would they come to right there? Again, going real fast makes wind happen. We don't feel that wind. So what did the ancient Greeks assume? Exactly, that we did not move, okay? So you can see how that is based on observation, and it's logical, but it's the wrong conclusion because they had the wrong idea. Because here's the thing. Here's what the ancient Greeks didn't know. Had any ancient Greek ever been to space? No. They didn't know that space was a vacuum like we do, and they also didn't understand gravity like we do. So they thought that the air that's right here, like this air right here, that this wasn't a part of the Earth. This was what the Earth was sitting inside of, and that space, outer space, was just this air up going on and on and on and on and on, and that if the Earth moved, they thought the Earth would have to move through the air, so that the air that's like in the room that you're in would be left behind as we moved. Now we know that because of gravity, Earth pulls its air with it. So we're not going to get wind because our air is not moving past, right? But they didn't know that. Like, here's the problem. I think the ancient Greeks might have figured this out a little bit better if they had cars, right? I think if ancient Greek people had cars, they wouldn't have had this mistake, because cars have windows, right? Cars have windows. Imagine you're in a chariot going 100 miles an hour. Nothing is blocking the wind, right? All the wind is coming past. But if you're in a car going 100 miles an hour, let's say your friend's like driving at 100 miles an hour in your car, and you're in the passenger seat, and the windows are up, okay? Do you feel the wind going past? No, right? You don't feel the wind going past. So that means that you would know that the car was taking air with it. And that's kind of the situation the Earth is doing. So ultimately, even though they actually had the idea that the sun might be in the center of the solar system, which is much more correct, they didn't end up going with it. For a bunch of reasons, okay? So, geocentric. They put the Earth in the center. So, I'm going to draw the Earth in the center right here. Here's my next question. Don't worry if you get this one wrong or right. What shape did the ancient Greeks think the Earth was? What shape did the ancient Greeks think the Earth was? This one's going to get interesting. What shape did the ancient Greeks think the Earth was? Yeah, so this is what I'm expecting to hear, because frequently this is what you're taught. So a lot of people, what you're answering right here is that the Earth was flat, maybe in the shape of like a flat frisbee or a disc. That is actually not the shape that the ancient Greeks thought that the Earth was, okay? It turns out, unlike what you may have been taught in school, the ancient Greeks were actually the people who figured out that the Earth was shaped like a ball, okay? It turns out that the ancient Greeks were able to figure out that the Earth was round, okay? They were the ones that figured that out. They thought it was a sphere, which that information has been muddled in school a lot. So check this out. Did the ancient Greeks travel all the way around the Earth? Did the ancient Greeks travel all the way around the Earth? And here, my head is the Earth. No. No, they didn't. So how did they figure out that the Earth was round? How'd they figure that out? So it turns out it was actually Aristotle who figured it out. This guy over here, who was wrong about the Earth being in the center, he was the one that figured out that the Earth was round. Okay? And how did he do it? He did it by looking at eclipses. Okay? And we'll talk more about what eclipses are now, but a type of eclipse called a lunar eclipse, when that happens, what you can do is you can see the shadow of the Earth on the moon. Every time there's a lunar eclipse, and they happen pretty frequently, you can see the shadow of the Earth on the moon. And every time you see the Earth's shadow, it's always a circle, no matter which direction the moon is in. So in other words, no matter how the Earth is turned, you're always going to see a circle-shaped shadow. And what's the only thing that's going to have a circle-shaped shadow no matter how you turn it? Okay? What shape's going to have a circle-shaped shadow no matter how you turn it? Woo. Looks like we're getting a little bit of a delay in the stream this time. That's okay. Yes, it's got to be a ball shape, right? It's got to be a sphere or a ball shape, okay? So the ancient Greeks figured that out, okay? And here, this is something important. It turns out that by analyzing shadows, the ancient Greeks were actually able to figure out almost exactly how big the Earth was also. They checked the shadows at noon on the same day in different towns, and by looking at the difference in how far the shadow tilted, they were able to figure out how big the Earth was, okay? So the ancient Greeks, even though they were wrong about a lot of stuff, they were the first people to be right about this. And that means flat Earth people, we figured that out thousands of years ago, right? Flat Earth is